Hello, hello. Hello, Penguin. All right, we're back. Yes. Yeah, the game jam had me tired, so I have taken a little bit of break, but now we're back, and yeah. So today I was thinking we were gonna look at a little bit of shader action, and I've basically already done like now I'm in my template project, and I've done like a kind of default setup here, and so we do have. I can show you around here actually, because I made a different implementation here for assets, and so hopefully this will be a little bit more generic and useful for more games. So I have this assets.zig file where I have asset containers, which is essentially a wrapper around a hash map where you have a key and a value, and then we have some convenience functions here. You can load stuff, and how do we know how to load things? Well, we pass in options, which you pass in function pointers to functions that actually do the loading for you, and also getting the file name to load, and also we have unload as well. So basically it's a little wrapper around the map with like loadable and unloadable things, and also file names. And then we have this general like assets struct, which holds basically all assets that are loaded right now, and the possibility to load in more assets. And how we do it is we have these keys for each type of asset. We have a key where in textures you have their own texture keys, sounds, music, and then shaders. So we can easily like talk about, okay, hey, load this shader, or use this shader, or play this music, and then we have all of our types here for the container. So here's the texture container, and we supply the functions that will be used to do the actual loading and unloading. And I'm just using like raylib's load texture, unload texture, because these actually just take a file name, and it can be an error as well, but our function takes care of that, and returns the texture. So that's the payload of this hash map, or the value type. So this is the key here, texture key, and then the value type here. So that means that we can like create an empty at first, and then dynamically load in any key based on the key that we want. And use it, so we can like load everything that's needed for a level, for example, and unload it when we're done, or keep the things that are like common between everything. All right, and then we have sounds, we have music, and we also have shaders. So let's look at shaders, because shaders is a little bit trickier, because load shader, raylib load shader actually takes two arguments. Takes the VS, which is the vertex shader, I believe is called, and then you have the FS, which is the fragment shader. So there's two shaders. Now the difference is that I believe the vertex shader can kind of move the vertex around where the vertex will end up, so you can kind of change the geometry of the thing you're trying to draw. And then the fragment shader is taking care of the color of the thing that you're trying to draw. So those two things are supplied here, I believe that's the kind of there might be, you know, a better definition of those things, but yeah, and I have a little script here, sort of, that kind of parses my thing here, because my interface only had one file name. I had to kind of do a little bit of hack here to kind of separate by semicolon. So as you can see down at here's the file names. So for example, my key for Spritesheet, I just say that, hey, that's just spritesheet.png. And then we have these ones which doesn't actually exist. So here we're basically mapping all the keys to the file names. And here's the shaders. So the shaders are a little bit different. They're kind of the same, but also different, because you have to have a semicolon here, where to the left of the semicolon is the vertex shader and to the right is the fragment shader. But if you don't have a vertex shader, you can just have it empty. And then if you have a fragment shader, you can do it like this. But if I had a vertex shader, I can like put it there. If I don't have a fragment shader, I can do this, you know. Yeah. So, yes. So there we go. And then the little script that they will handle separating them and, you know, getting the real file names out and passing it to Raylib there. So anyway, that's our first step, like actually loading the shaders. And I showed you this assets thing. And then, you know, how I use the assets, this asset structure, is I simply initialize it with an allocator and these init options, where it's like, okay, do you want to load, like if you have a small game, you might want to just load everything at once, or maybe you just want to load the textures and the sounds but not the music or something like that, or you just start out with an empty and you load everything as you go. So empty would be not loading anything, but yeah, we can call load on a specific resource or asset to actually load it. Okay. So yeah, so we simply just add this as a singleton, and then I have an assets function here, which yeah, it just gets the singleton out for assets. And then you can use assets to, for example, load. Well, you type, where do we do this actually? Assets dot something here. Oh yeah, here, for example. So if I want to get the texture and I can supply the texture key. This is a convenience function also in game here. I can get the assets, I can select textures, and then I can load with the key. And this load function actually uses them if we've already loaded it in, if it's like already in the cache, let's say. We're not going to actually load a file in, even though we call load here. We're just going to use it, like return the cache. So if you call this function, it's going to call this one. And it's like here. It's like, okay, well, we're looking in our map. Do we already have a key? Then we extract the value out and we return the value. Otherwise, we will get the file name. We will load using the load function that comes from the options, which is for textures is raylib.load texture, for example. And then we get our value out and we put this in our maps, saving this value, and then we return this thing. So this load function will get you the thing, even if it's not loaded, or if it's already loaded, it will return the cached value. So there we go. So you don't technically you don't have to like preload using the system. However, then you know you might get some lag if you like dynamically load everything like this. But But you will probably want to have some. I'm probably gonna add like a scene loader thing, or like a preload thing where you can gather all the different resources that you need in a struct, and then you just pass that into the assets container, and it will like load all of those things and maybe unload everything else that's not needed or something like that. I'm not sure. So yeah, that's the thing. And then but let's go back to the shaders. So for shaders, we have the same thing. We have a shaders container, and we just load the shader. So here now we get our raylib shader here, and we just call now you can just call begin shader mode from raylib. However, there is a prerequisite of this. Let me go to draw. And where is this happening? So basically what's changed here is that now we have a render texture as well. So the render texture is basically, so it's basically how does the shader work? You know, if it depends on the shader that you want to use, I guess. But it's like, this is kind of like a 2D full screen shader that I am currently looking at. So I can show you the shader actually here. Actually, why do I have this one? I don't think this is the... This is not correct here. I think I copied some other shader here. I'm gonna remove you. And then this is the actual shader here. So this is it's kind of a combination. I kind of copied some code and then I made some own my own, but yeah, in the end it's a lot like what you would find like online here. But essentially in raylib you get these input things automatically, I think, because I'm pretty sure you have to like manually set this up if you're using like, you know, if you're just using like OpenGL or something. Like you don't get these ones. I'm not sure actually, but like invec2, like there's some things you have to set up, but this is automatically set up. You don't have to do anything in our code for these to get populated essentially. So in means like an input variable essentially. This can vary between each render, I guess, or each each what's it called, each call to this shader essentially. So every time you get a new, so how the shader works essentially, it's like you're going through each like kind of like pixel or thing in on the texture of the shape that you're drawing. And the thing that we're drawing actually is this render texture. So that's the thing, like we're drawing the whole screen. Hello Ivana Yushchenko, what's up? Welcome. So for a full screen 2D effect, and this the shader that we're using is a CRT effect. Okay, so it's basically going to be a full screen effect. And so what we're doing is we're turning our whole screen into a texture. So how you can do that, essentially you create a render texture, you begin texture mode in raylib, and then you use usual draw functions, and then you end texture mode, because now you're drawing to this texture instead. It's a render texture, you can draw onto it with the begin texture mode, and you end texture mode. Now we have a bunch of things drawn to this texture. And now we do the actual drawing to the screen. So we do begin drawing, and now we want to apply our CRT shader. So we begin shader mode there, and then we draw the texture. One thing to note here is where we flip the y-axis because the texture is kind of like upside down for some reason. So you always have to like negate, but it's easy enough. You just have to negate the Y here. But yeah, so that's why that's like that. And then you end the shader mode, and then we end the drawing. So that one now we've drawn the whole. We've first drawn onto this random texture, and then we draw the texture out with shader on. So the shader will apply to the whole screen like that as a texture. Like so, essentially, this shader is going to be called on the whole screen, and so. Yeah, and essentially we only have like a fragment shader which only changes like the color of the thing. Well, if I can show you the results here. So this is the CRT shader, and you can change a bunch of things. So what we have is essentially we have a kind of a bending effect. So it kind of looks like those old time screens. We have the scan lines, which makes, you know, like lines here. And we also have a vignette, which makes the corners darker and center a little bit brighter. Or, yeah. So now it kind of looks like, you know, an old monitor screen here, basically. And what we can set here, we can set, let's see, the radius. This isn't used. Yeah. I'll get rid of these. I'm not sure if these are used. These are used, actually. Yeah. This is set from outside, actually. So these are one of the few things that are actually, you can, like, everything that is uniform here, we can set from outside. These things are actually populated by Raylib, I think. So you don't need to set these, but yeah, they are automatically populated by Raylib, so you can access like the texture colors or the texture, you know, pixels, and the diffuse color, which I believe is like the color on the curve of the thing. I'm not sure. I seem to remember diffuse, but I don't actually remember exactly what that means, right? Actually, let me look this up here. Graphics programming diffuse color. Matte color. Okay, so it's just it's like the unlit color of the current pixel. Actually, I'm not sure why we use that. Oh, right. We use that because we want to... No. Okay. I'm not sure, actually, because the final, like, color is supposed to... Since we're bending the screen, the position of the color is, like, ending up somewhere else. So I don't know how this makes sense. What happens if we just remove this? Nothing. What? Also, what's cool about this is you can modify the shader, and because that's like compiled in real time. So if I modify this, I can also like modify, let's say, I can change the distortion of the curvature. And you can see it changes. I don't have to recompile the program. It's gonna recompile the shader in runtime. And if I go over to the side, wow, the lines look really weird. Maybe it's just because they are like pretty thin. And then there's other things that we can do. Distort X, for example. Now the other side is like distorted. We can do both. Now it looks like this, so yeah. And then we have like scan line intensity. If we set this to 0, there's no scan lines basically. If we set it to 1, the scan lines are basically gonna be like black. You're basically not seeing what's in between now. If we can also change the thickness of the scan line. So if I set this to 10 or 20 or something, then the scan lines are way larger. And if I set this to like 0.1 or 1.0, you can see that, yeah, it changes these things around. Something like this, or maybe something like this. I'm not sure actually what the size of the scan lines. I mean, I guess you would have to see what you would want there. But yeah, those are the kind of the settings that you could set in this particular shader that I made here. And this is available on, if you want to check it out, like on the GitHub. Maybe I should update the the description here to actually to this template project actually. So let me do that real quick here. And all right, so it's in the description now. Okay, cool. So basically, yeah, that's it. I mean, now we have shaders. The only thing is like how we actually like make the shaders do what we want to make them to do. But yeah, this is like one example. You can do a whole bunch of things with shaders. There's a lot of examples on Raylib. I can show you here as well. Raylib. So let me show here, Raylib shader examples. You can go to examples and click on shaders. And here's a whole bunch of different shaders. Now these shaders are also, they can be different types of shaders, like basic lighting. This is more like a 3D. I'm just focusing on 2D. Here's like an ASCII rendering shader. That's very interesting. How that works, I'm not sure. Would be cool to check it out. Model shader. So that's essentially how you can also apply different shaders to different like objects, because it's only applied to the things that you draw when you like draw it, like when the shader is enabled, and you can enable another shader or another group of shaders, maybe even. I'm not sure actually. Actually, can you have multiple shaders at the same time? I'm not sure actually. Maybe you can't. But anyway, what's this? Shapes, textures. Yeah, so, and then this one, custom uniform. So yeah, this one, this is the one that I was like basing my shader on, because it like applies to the whole screen sort of. It just so this shader is like, you know, it's swirling around the mouse pointer. So essentially you're passing in like, where's the mouse pointer, and you're passing in how large is the screen and a couple of other things, and it's gonna calculate, okay, how do I need to modify the colors to look like it's swirling. So a lot of things in shaders, like a lot of mathsy things that you have to do to make it work. Or you can just find a shader that you, because shaders are like universal, because, you know, it's its own program language, or it's like you can easily find like OpenGL or GLSL shaders. And also one other thing here, if you want to actually look at these shaders, you have to go to the, because you can't find the shaders in this particular screen or page. you have to actually go to the GitHub of Raylib and then go to examples, I believe. Raylib GitHub. And you have to go to examples, and here we have like shaders, for example. And so here you have the resources, and then here's a bunch of textures, and then shaders, and then select the version. I'm not exactly sure which version is best to use. I assume it might be the latest one, but there has to be a reason why we still are on like 1.0.0. Maybe it's like you know, compatibility with older graphics cards or something like that. I don't know. I just chose version 3 for some reason. No reason at all, actually. Yeah, and here's the swirl fragment shader. So that's the only shader that existed for the swirl. So here's the whole shader to make that swirly effect, essentially. So it's pretty simple, actually, because it's just a bunch of maths happening here, dot products, and yeah, sine, cosine, and stuff happening here. Not sure exactly how it works, but there you go. So you don't have to kind of be a maths expert to do this stuff. And there's probably, even if you don't find source code, you could probably find like some kind of equation or algorithm, or just ask, you know, AI to make the shader for you or something like that. Because that's what I did also. Like I asked AI to kind of, hey, could you help me with this one particular thing with this shader? And it did actually help me out there. So that went really well. Yeah. But what I wanted to do, actually, I wanted to kind of investigate how we can do God rays. And let's see. First of all, and I guess if you want to have multiple shaders, one thing, even if you can't enable multiple shaders at the same time, maybe what you can do is you can draw. Actually, I'm just gonna try this. If let's say we begin shader mode 2 times, what's gonna happen then? It's gonna crash. I don't actually know. It didn't crash. Maybe it just overrode it. Hello, Mabdo88. What's up? What's up? Welcome. Okay, what if we made another? So this is how I'm adding another shader. I'm just gonna do a quick example here. So we're adding another shader. Now if I save this, I get these errors that I have to fix. So we need a file name for this shader, which I'm just gonna say it's this. And that's it. And now the shader can exist in our game, but we have to also actually make this file exist. So I'm gonna go here, I'm gonna copy this. I'm gonna edit crt2.fs. And I'm just gonna keep it the same, maybe I'll do a bunch more distortion so we can see like a difference here. Okay. And then we'll go to draw, and now we can activate both of these shaders and see what that does. Maybe it just overrides the thing, and then I'm gonna change the angle or the order here. Okay, so it seems that we can only have one shader, and the shader that is on is essentially the latest one that is enabled. So cool. But what I was thinking is that, okay, well, what if we want to have multiple shaders? So if we want to have multiple shaders, I believe one thing we can do is essentially, if I draw this texture, so okay, let me create another render texture. So this is my idea. Like, you create one render texture for each shader that you want. So I want to create another texture, although this is kind of weird. Will this even work? Yeah, it will. It will probably work. It's just the order of what I have to apply CRT last, because it's gonna distort and stuff and do weird stuff. So render texture 2. This is essentially gonna be like create render render texture, load render texture. There we go. Screen size X, and of course I have to cast here. Is that it? And then this could be an error, so I'm just gonna catch unreachable here. Okay, and we don't have screen size. Screen size, that's strange. Oh, it's down there, okay. Well, let's do it like this. Okay, so now we have render texture 2, and we can begin texture mode to draw onto render texture 2. Instead of drawing to the screen, we're gonna draw to render texture 2. However, we are gonna then in the end apply the shader mode to render texture 2 the texture. But we do begin texture mode and we end texture mode. We also begin shader mode, CRT2, and then we end shader mode again, and we also draw the whole thing. Okay, so first time around, we're drawing onto render texture. Oh, 1 second there. All right, sorry about that. Okay, I'm not sure how good a method this is. I mean, of course, we don't want to create this texture every frame. We probably want to keep a texture around, you know, and not create it every frame. But I'm just doing it as a test here. So first we're drawing onto texture, onto this render texture. We're drawing every, like, you know, the game, the raw game stuff. And then we're applying, then we're drawing onto texture 2 to apply CRT2. And we're drawing the render texture onto this other render texture. And then I just realized you only need 2 render textures, because you can just flip between them now, because the old one is essentially, it's just discarded essentially. So we don't need more than 2. If we wanna keep doing this, we don't need 1 render texture per shader. We just need 2 render textures. Okay, And then we actually draw to the screen, we draw the render texture 2, and here we apply the second shader. So this is how you probably can you like have several shaders, like full screen shaders at the same time. And now it's kind of looks super weird here because, yeah, it's interesting that I thought we would get like a lot more weird stuff going on since we're applying 2 distortions to the screen, but we just get like a mix of both things here. Yo, code guy, what's up? What's up? Okay, so because what I want to do is like have the God rays happening here. So let's say this is God rays. And I'm gonna rename you to God rays. Okay. Should still have the same thing happening here. All right, so the God rays, I'm gonna remove basically everything here. Do we need render? Yeah, we probably want that maybe. For some reference here. Oh, excuse me. And here's the distortion. We're not gonna distort. You know what? I'm just gonna do this. And I'm gonna check here. Okay, we actually got a compiler error for the shader. Undefined variable color diffuse. Oh, the color diffuse is invec for I think. What the hell? No, cold diffuse. Wait, why is this uniform? Because uniform essentially means that it doesn't change during the render. Interesting. Okay. So frag color then. No? Let's go back here. We got the text coordinate, UV, texture 0, texture. Okay, so we are going to... Okay, here we go. This is the color that we want. Frag color, diffuse. That's the texture color. Okay, and then we ensure that we have full alpha there. Okay, there we go. However, it's still not. Wait, okay. There we go. No, still compiler error. Distorted text. Oh. Brag text format. There we go. Okay. So, I don't know why my face full of football, don't even watch one. Is it like the finals now or something? Holy Sigma Mel, you know it. Right. So this is now kind of like an empty shader here, where I'm fragment shader. I'm just passing in these things here. Now we want to supply render width and render height, I believe. So I'm gonna do that as well. But they are defined kind of like a default value. If you don't supply them, they will get 800, 450. But we can't supply them, and to do that we have to go over to here, and I'm gonna go to what's it called? Shader location. Right, set up shader. So here's the CRT shader. We're setting up the CRT shader, and then I'm gonna copy you for the God Race shader. And here's the render width location for the God Race. You know what? I'm gonna make separate functions here because it's annoying to have to rename these variables. Set up CRT shader. And I guess I'll just copy you and set up God Race shader. And then up in here, we're gonna say set up CRT shader and set up God Race shader. Okay. Now we don't have these things. Actually, this doesn't have like center either, so center is not even a thing. We don't even care about center here because that was from the swirl thing. Okay, this is the shader. I'm gonna rename you to shader just to keep things generic here. And we don't have center location. There we go. So now we're setting width and height to the screen size that it should be. All right. And of course, nothing's changing because it doesn't actually do anything yet. However, I was asking like, okay, how can you make like a nice, you know, God Race shader in, well, yeah, a shader. And I was asking AI here, of course. I mean, there's probably tons of examples. But you just get like, no, that was not it. This one here. Actually, maybe there is post-processing. That's okay. So you actually, hang on, you don't see it. We have more examples here in Raylib. I thought that maybe we could see if there was something here for God Race. We got texture rendering. 1 second here. Right, I'll BRB like a couple of minutes here. I have to go down and talk to someone here, so be right back. Okay, sorry about that. I'm back. Make an Earth using Raylib. I don't know. I don't think I've ever done that. Okay, well, I immediately think of 2 different approaches, but... Or maybe 3, actually. You could do maybe like sign distant fields. Or... Maybe, I don't know. Or you could do vertex shader things. Just making a model, I guess. Or just a flat planet, which is probably the most accurate if you want to render it from like, you know, a lot of distance. It's gonna look like a flat sphere. Thank you, Cold Guy. I appreciate it. Thank you for the welcome back. All right. Let's see. What's this? Texture waves. Oh, nice. Looks like a surface of water. The Julia set, which is, of course... Oh, so you're using the shader to render a Julia set. Cool. I can change the speed. Wait. Oh, what happened? Not sure what's happening when I press the things. Oh, I can zoom pretty far. Oh, here we go. Here's the limit here. Yeah. You have to do more iterations if you want to go further down. But that's nor here nor there. Do another game jam. I plan to do other game jams. It does go infinite if you... Well, you know, mathematically it's infinite. But you're limited by the computer resources to actually render it. And here's the Mandelbrot set. Do you know what this is, Cold Guy? Oh, you can actually change the number of iterations. So look at this. It's a dynamically changing the number of iterations actually as you zoom in, because you can kind of see things gets revealed. And here's the limit. Why is it limited so like this? This looks weird. Use 1. Is it like precision? We're getting to the precision limits here. Yeah, probably. Maybe. But yeah, anyway. Yeah, that's cool. We got color correction. Okay, we've got... What the hell is this? Sieve of Eratosthenes, earliest known prime number sieve. Oh. Okay. Fog rendering. That's pretty cool. Simple mask. Oh, so you draw like behind. I see. Cool, cool. Hot reloading. Oh, so you're like changing the shader in real time. Mesh instancing. Multi-sample 2D. Interesting. Normal map, spotlight. This is kind of what I'm looking for. However, this one is like super simple here. I mean, I would essentially guess that you just render everything. Like you have a couple of points where you have lights, and you also have like a radius, and perhaps like a fall off or something. And and then you calculate what's the distance from these points. If it's like close enough, you render it full color. If it's outside, you render it dark. And in this zone, you render it like somewhere in between. Deferred rendering. Hybrid rendering. Yeah, so different shaders for different objects, maybe. Texture tiling. Ah, nice. Shadow maps. Here we go. Vertex displacement. You could use this to like do like the surface of a sphere if you wanted to do like a planet that looks, you know, unrealistic. Depth writing. At least in what I'm thinking in my mind. Light maps. Man, there's a lot of things here. Depth rendering, game of life in a shader. RLGL compute. Cell shading. Okay. Right. So there you go. There's all the examples in Raylib here. Kind of curious about this post-processing thing. Grayscale posterization. This like decreases number of colors. So you kind of get this like, I guess, old Quake feeling here or something. Dream vision. I'm not sure what this is. It's just, okay. Kind of like a cinematic thing. Pixelizer. I mean, I'm a fan of this. I know maybe a lot of people are not. I'm not sure when this is used artistically or like in a cinematic maybe. I mean, I know about Return of Obra Dinn, which used not really this technique, but a different technique, which looked awesome actually. Cross-stitching. Predator view, okay. It's just like a hue rotation or something, I don't know. Scan lines. There you go. There's the scan lines. Although these look more like white things going over the actual colors instead of black lines. Fish islands. Sobel, like edge detection. Which is actually pretty cool because if you have an edge detection shader, you can use that if you want to like draw a model that is currently being selected or something like that. Or hovered, if you want to draw an effect like a line, an outline. And here's bloom, where everything is bright. And blur. Is it just me, or is this kind of blurry as well? Not really blurry, but the kind of... I'm getting like double vision here a little bit. Maybe it's just me. Okay, there we go. That's all of them. And all of these shaders are available over at here. So Raylib, and then examples, shaders, resources, shaders, and then a version here. And here's all of these shaders here. So scan lines, for example, very simple. They have 2 different versions as well. What was that called? The Bloom. Pretty simple here as well, actually. And then we also have ASCII is kind of interesting. I'm not sure how they do this. Do they load in like a texture of characters that you also look at? Get character. Okay. So we have pixel size with cell UV, cell color. We have grayscale. N is 4096. Character set is from this. Create new bitmaps. Wait, are these actually like small, like bitmaps, or it's like pixels, like on or off? So essentially, it's like a raw data of this encoding, like this symbol. Into some type of how large? Okay, well, anyway, yeah, so that's that. But what we wanted to do was this God rays. So according to AI here, 2D God rays are created by layering an oscillating noise gradient over the screen and using a blend mode, additive, or screen, so light shines through atmospheric dust. To implement this in Godot, you can apply a visual code snippet, a color rect node spanning your camera's viewport. So essentially something that spans the whole viewport. Okay. Implementing 2D God arrays is generally split between screen shaders and ray marching screen space techniques. Yo man, do you know how to make the slice file in React Redux? It went too long after the create async thunk. I basically never used Redux. Like I've used it a little bit, but not to that extent. Are you actually? What do you mean slice file? How to make the slice file in React Redux? I'm not sure what you're talking about. How to make it smaller and modular? I would have to look at the code and understand what you're trying to do in order to help you. Like I can't really answer as such that question straight up. So unless you can explain that in another way or give me more context, I can't help you. But I can help you. I mean, I'm up to helping you, but you have to kind of provide me with more information. One simple 2D screen shader. This shader creates shimmering angled beams of light over your background without needing complex occlusion masks. Add a color rect to your scene, resize it to cover your viewport, and create new shader material. Okay, well, we can do this without that anyway. Okay, so we have like a color, we have a bunch of stuff. So this is only one ray. No, there's two rays, I guess. I mean, what we could do is we could just try and copy this over and use it directly and then translate it to whatever method we're using here. So I'm gonna do this, and instead of color, it's gonna be final color. I think though that this is probably something that will have some, like, this is not the entire story here. And this is main. UV is I think frank text chord is kind of weird because it goes from, it seems to go from -1 to 1. And so to get the UV coordinate, which I believe could conventionally is from 0 to 1, I think. So we have to do +1. So now we got from, wait, or is it the other way around? Let's look at CRT actually, just to make sure here. Yeah, this is the thing. It times 2 minus 1. Wait. No, it's the other way around then. Then UV becomes -1 to 1. I don't think. Oh, because we want the center to be 0, maybe. That's why. I don't know. All right, let's look at what you've got here. Oh, why is it not? Okay. Okay. By the way, why are you using this function? Like, are you following some sort of tutorial or something? Check this one. Ignore the interface part. Check from create slice part. Okay. Yeah, so as I said, I'm not super familiar with Redux. I've been using, like, I haven't created a Redux like architecture. I've only used it before. So I'm not exactly sure what a slice is or what this is actually doing. But you know, it's obviously creating some sort of observable thing in some way that you can do actions to or something like that. Yeah, we have actions, clear task error, and reducer. Okay, so slice. I mean, to me, slice insinuates multiple things. But here it could mean just, you know, a technical term in Redux to mean some, like, a collection of a slice of everything, essentially. There's a good way to use async time for the API instead of using a different folder. Okay. So we have task, initial state, okay. Reducers, okay. Extra deducers. So what is the what? Okay. Create async thunk. Where do you have it? Fetch task, create task. So is it here, you mean? That this is taking time? Could you please join on Twitch instead? Because this is going to take forever otherwise. Because every question I have to wait like a minute for the answer. Also, genuine question, like why are people using Axios? Like, why just not use the built-in fetch function? Why do we still need a library for this? What do we give from this? I've never used Axios before, actually. Hey, cool guy. All right, so just where is the issue? Where's the error happening? I'm not sure. I don't think I can help you here actually, because I'm not super familiar with this. With create async thunk or you know, reduce like Redux in general. And that was that. Cannot we make the create slice part modular? Like you want to break out? I mean, yes. Why couldn't you? You already have it modular because this is defined somewhere else. Right? And then you're just using it here to create the slice. So just break out, like just take this, put it somewhere else, import that here, put extra reducers, you know. I'm not sure what the issue is. Okay, yeah, no problem. I was thinking that you wanted help with the error you got. I mean, it's still gonna take as long. It's still gonna take, you know, the same amount of time. Because we're not optimizing it. We're just breaking it out. Okay, well, I don't know. You should just, yeah, I guess you should look into like how to optimize that, because I don't know. Okay. No, I know, but Redux might have strategies that you can use to optimize the usage of that function or something like that. Like, why does it even take time? Like, what are you waiting for? You love shaders. Sababugs. Welcome, welcome. No, it's not me. I have never seen that before. Cool guy. Okay. Anyway, wait. So this one, if frag text core was -1 to 1, then this would be like -2 to 2 minus 1, which will be -3 to 1, which doesn't make sense. So it has to be the other way around. Like we're creating. Yeah. Okay. So let's go back here. So frag chord is, I think, is already the way we want it to be. Frag text chord. Color. Okay. +1. No. So that's just that. And I'm gonna remove. No, I'm not gonna remove these. So we have all this. We have a noise thing, hybrid noise. What shader lang is that? So this is Raylib's. I'm using the shaders with Raylib. The language is, I think it's GLSL. I'm not like a shader expert or anything. I basically copied a thing from AI in here, and I'm trying to make it so that it works with Raylib here. So, and what I've done is essentially the UV should probably be good now. I'm not exactly sure what this is gonna produce, but I guess we'll see. And then the final color, this color is it's the actual color on the screen out. So I think this was meant to be used in conjunction with some other effect in Godot. But I guess I could ask AI to, hey, could you do this in Raylib instead? But we'll just see what this is gonna do. So let me go over to draw here and see. One thing that I will do is move this creation of the render texture out from each frame and put it in a thing instead. So let's go to, I guess, where are we doing this? Actually, we're doing it here. I'm gonna do this. I'm making a struct called render buffer, and in here we'll have two render textures. So we'll have render texture A and render texture B. And then we'll have, I guess we'll put an init function here. And actually, oops. The 12, you remember the 12-hour triangle? Yeah. My beer is unfortunately empty now, so. Try configuring restream. You can show both channel one go. Maybe. I don't know. I mean, I am seeing both chats, but you're not seeing both chats. So render text A is equal to try raylib load render texture width and height. Actually, yes. And then your same thing. And what we need here is the screen size. And no, that's it, I think. And that width is an I32 int from float, screen size X, height. Okay, there we go. And then setup is actually not creating this. We're creating we're getting, let's actually do this. Render buffer is import render buffer. So now we can say render buffer equals try game render buffer init screen size. And we add that as a singleton, and now we can access both of them. Cool. Okay. So now in draw we will get render buffer A. Actually, render buffer is texture B. This is texture A. And this is texture B. Dot texture, right? Okay. Cool. It's kind of slow, actually. Yeah, it goes down to 30 FPS. Okay. Is it like, okay, what if we did CRT twice? Kind of hard to tell, but I think it's like 60 FPS now. I was thinking if the action of drawing twice and doing things twice, if that slowed FPS down. Or maybe it's the God rays thing itself that, yeah, interesting. We changed the shader. This drastically drops FPS on me here. 30 FPS. So what if we only do what if we do not do this, but we only draw texture A instead? Okay, 60 FPS, I can see it. And then we change to God rays. Interesting. Why is this so slow? It's almost like it's locked at 30 now. Yeah, I'm gonna disable CRT for now. I will check. Do you travel? Not that much. Why do you ask? Wait. God race. Oh. Wait, there's a whole bunch of errors. Maybe that's why things are not working. I should have looked at this first. Okay, OpenGL does not allow CG style semantics. Okay, so there's some issues with the code that I got from the AI here. So let's look at this. 18. Okay, hint range does not allow CG style semantics and unexpected thing expected blah blah blah. Okay, so I guess this is not working here. Ray color, source color, like, yeah, I don't actually know what this is doing. I think maybe Godot has its own kind of language here. So I'm, yeah. So it's like, I guess it's like auto connecting the source color here. Here is like, you know, you can only set it in some range. What I'm gonna do is I'm gonna make a macro here. I'm gonna find you. I'm gonna delete you. And then delete until equal. And insert space. We're gonna go over here, do this, paste that in. Go back to this. Okay. And then there was some stuff missing, maybe. Okay. Oh. Undefined variable frag text chord. Right, it's text chord, not text chord. And then it was also undefined variable time. So time is something we need to pass in, I believe. I'm not sure if Raylib does that automatically. I'm gonna check this. Raylib shader time. Okay, so we can pass it in because it does, because Raylib does pass in a bunch of stuff like automatically. So, but essentially, yeah, we have to create a location, which essentially is just going to be it's going to be something here. So it's going to be like uniform float time. And I guess if we don't put in time, it's just going to be 0. And so instead of saying time here, we do time like this. Okay. So now we get, oh, hey. Yeah, so this, but this only works, okay. So this is kind of the idea, I guess. But it only works, it's like an overlay. It's supposed to be kind of blending into the background. Who's your favorite programmer? I don't have one favorite programmer. It's me. I don't know. Yeah, that was actually kind of cool effect, but it also did not do what I wanted it kind of to do. So Are we doing anything with the original colors here? I don't think so, right? So we can do that. And then I'm not sure how to blend here. Like, I don't know how to do that. What if we just do this? How's that gonna look? Oh my god. Whoa. Why do you get like a weird like echo effect or follow kind of thing happening here? Okay, one thing that I want to do is I want to how do we make this into kind of like an overlay, like a blend effect? Now, I mean, I guess we could just ask AI actually. So where's that thing? Okay, so now how do I implement this shader in Raylib? Wait, so now oh my god, I hate it when that happens. I've implemented the shader in Raylib. However, I'm having trouble with blending the rays onto the screen, onto the, I mean, game graphics. How can we do this in the shader code if we have access to the original screen color of the current coordinate? The blending code. In your fragment apps, the blending additive or screen blending formulas. If you already access to the screen, you perform the mathematical blending right before assigning your final color. Here's how you do it. Okay. So, yeah, we have original plus final ray, additive blending, blending. Can blow out to pure white. Screen blending, software cinematic, never blows out past pure white. Formula 1 minus 1 minus target times 1 minus source. So you're kind of inverting, I guess, the target and the source, and then minus or timesing them, and then inverting that. Okay, let's try this. I mean, we could try both, I guess. Cool. So original color is just going to be, that's just as color. And did we have final ray? Was it called final ray? No. It's called ray color. And we'll try this one first. And oh, final ray is okay. Rec, is it rec 3? Wait, where's ray color? Oh, it's up here. Okay. Rec 4 ray final is ray color times ray intensity. And then blended color is interesting that it changed the now it's Raylib, the convention changed. However, we're in Zig, so we can choose our convention to be this instead. Okay. Interesting, because the alpha of the ray does not translate here. And here we actually put in 0.8 as a default alpha, so I'm not sure what that... I'm pretty sure the alpha just discarded here, because this is a vec3, and this is a vec3, and this is a vec4. But if you want the target to be vec3, and you do this operation, I'm pretty sure it just throws away the alpha. I think. Okay, because it's not like it knows it's the fourth thing in the vector is a color, is the alpha, so it automatically does things here. But yeah, anyway. So yeah, so that's now the final color, and let's see how that looks now. Interesting. I mean, what if we drew... Let's just draw a bunch of lines, I guess. I can actually... Let me just draw like a background here. Hello, Subadara. What's up? Welcome back. Long time no see. Yeah. How are you doing? I'm also using Raylib to make an engine. Nice. With C++. Sorry, no Zig. Oh, man. That's no good, man. But anyways, I hope the progress is good for your project. Yeah, I'm just doing a bunch of random stuff now. I'm taking a little bit of a break. Someone got bit by a snake. Well, oh man, that is ouch. I'm gonna create a new image. It's gonna be like hello Phil, what's up, I'm just gonna make it like 300 by 300 maybe, and it's gonna be, I don't know, man. Why is the mode set to grayscale? Actually, can you do like a gradient? Okay, it doesn't have to be super good here. I'm just doing that. Oh, interesting. Let's keep it like that. Well, whoops. Okay, there we go. Okay, I just want something that will show up. So this one is okay. Right, and then we copy over that. Face shader. Yeah, to sources. Wait, I don't have that. Okay, let's just do BG, PNG. Oh. Right, where I'm in the wrong folder here. BG into templates, source resources. There we go. Cool. And let's go over to our demo. Let's actually go to assets. And we'll add a background texture. There we go. And now we can use that. So we can draw that somewhere here. I guess we'll draw it first here. Draw background. Oops. So we get the texture is assets, textures, load, and the key is background. So there we go. Now we get this, or we don't do anything if we don't get it. So now we have the texture, and now we can draw it. So we can do draw texture, I guess V texture. Position, I'm just gonna do 0, 0, tint, white. There we go. Okay, so there's our little texture. And I don't really see the gold rays doing anything. Maybe I picked it too bright. No, because we have undefined variables. Oh. Right. Original color does not exist. It's just color. Final color does not exist. It's actually final color like this. Was that it? See if we got some errors here. Yeah. Cannot cast implicit cast from vec4 to vec3. 70. Okay. So this didn't actually work. I'm actually gonna do vec4. Is vec4, I believe you can do this here with an overload. No, that doesn't work. No, wait. No, it's just gonna be color times, no, plus ray final, except maybe the alpha, no, the alpha won't be plus. But, okay, I guess it's kind of weird. The alpha of the ray, how do we blend that with the alpha of the original color? So I guess this makes sense. We do this instead. Okay, there we go. Wow. There we go. We got some God rays happening here. This is the additive version. Of course, we can change other things as well. And then now let's try the screen blending version. I believe here we also have to say RGB here. Okay, so this one is a little bit softer. It's still extremely bright in the center here. I'm just gonna refill my water. I'll be right back. Okay, so now, I mean, I probably want to change this around a little bit, but before we do that, I want to try and see if we enable the what is it, the CRT shader. So we'll do that. You are CRT. You are texture B. Yeah. So now we should like combine kind of both shaders here. So first we have the God ray shader being applied, and after that we have the CRT shader being applied. So there we go. We have two different shaders going on at the same time. Yeah. So I mean, that's the basics there, and now we have to basically I guess, I mean, what we could do is change this to look better. Also, the CRT is also pretty, like, we get these, what are these called? Moires? I'm not sure what they're called, these patterns here. But we're getting some weird things going on here. So I'm just going to actually disable CRT for now. And change it to God rays back. And we go back to A there. So now we're back to this here. Cool. And then okay, so what I want to do is I want to see if we can change this up here a little bit. So the God rays, I mean, essentially it does kind of go down like this, and then it's like a band here, a band of noise that limits. So I think the limitation here is like based on a cone up here, but then down here is also, and the kind of noise that the purlin noise or whatever noise function is doing here. Oh man. Well, I think what we can do, maybe we can remove the mask, the cone mask, and have it like do all the way, but lower the noise magnitude a little bit, so you get like less overall, but we spread it out over the whole screen. So let's see if we can do that. I'm not sure where the cone is applied. Maybe it's this one here. Spread 0.5. Okay, what if we change you to 2? What happens then? Okay, this is kind of more like what I want. I don't know, maybe there shouldn't be a mask. Like, what if we just not use the mask at all? Okay, now it's more like how I was thinking, except the noise is kind of, it's like very magnetized here. Or it has a lot of magnitude. I want to basically decrease that. So I mean, yeah, we could just decrease the intensity of the rays. Interesting that there's like, yeah, there's 2 rays, the densities. Does that mean there's 2 rays? I'm not sure what that means. Is this even used? Yeah, it's used over here. Okay. Position 1, position 2. Oh, I see. So these are like 2 different noises happening. Hybrid noise. There's a whole bunch of stuff happening in here. Okay. What if we introduce... So we got fall off, edge fade, right. Let's do like 0.02. Maybe. Not sure. Or let's do 0. Okay, that broke it. Smooth step. 0 to 0, UV1. Okay, what if we don't do this? Then we don't care, right? Why do we even have this? Fall off? I'm not sure what that is. Oh. So this might actually be the thing that I'm looking for. Cut off and fall off. Okay, so fall off and cut off is like determining the intensities of all the rays. So there we go. Now we got like something that is more what I was thinking about. Whoops. Now the thing about the God rays though is that they don't really look like this in real life, because they kind of look like they all come from the same place, or they look like they come from the sun, of course. Well, I mean, if you would look I guess if you look without a perspective, this would actually be how it looks if the sun is like up to the left here. But if you were looking with a perspective projection, you would actually see the God rays like come at different angles. But I guess this is fine. Cool. Okay, so there we go. We got a little shader demo going on here. Are we creating Super Mario? No. But okay, I'll show another thing that I did with this template project. I did a preset, so I implemented like basic controls for both like top-down and platformer, and some settings as well, like gravity, air drag, and stuff. So I can, if I want to make a platformer, I can go in here and change the preset to platformer, and now we're a platformer. So now we have gravity. I can jump. I have coyote time. If I can actually use it properly. See? I have input buffer to jump. Yeah, so I implemented all the basic like platformer stuff here. And then if I change this back to top down, now we're in top down mode or twin stick shooter mode or whatever. So now I can, you know, float around on the screen here. Yeah. Cool. Okay, another thing that I want to try is essentially having like a shader for one object, maybe. See how that works. So what we could do is like attach a shader to a one entity, perhaps. So let's do that. So let's see if let's say we go to draw, and now we have like draw renderables, for example, and we will draw a renderable, but we also want to get a shader. Try get a shader, which I'm actually just gonna do this here. Okay, so if we have a shader attached to our entity, we are going to use it. So if we have a shader, actually you can just do this. If this, we get a shader, and we can do raylib begin shader mode shader. Actually, you know what? I want to do instead? I want to attach a shader key. And then the game is gonna like begin shader mode with this shader key instead. Yeah, so we don't have to copy the whole thing. And now we can also load it and everything properly here. And here we end the shader mode if we had the thing. Okay. So technically now we have support for shadering any object right now. So what I'm gonna do is well, first we need to create a shader, I guess. So first let's go to assets. We need to add another shader, and I'm gonna do like Sobel, because I'm gonna copy the one from raylib. So we have Sobel, which I'm guessing, do we need, Okay, I'll go to Raylib and see what we need for this. Raylib GitHub. Examples. Shaders, resources, shaders. What was that? Sobel. So there's only a fragment shader. Interesting, because it's like, how does it paint like outside of the actual model? Maybe it doesn't actually do that. But I'm gonna copy this. Will you play games any day? I don't know if people want to see me play games. I played a little Animal Well. What? Okay, Code Guy, what game do you want me to play? Oops. No. Here we go. So there's the thing. And we don't really need... Well, resolution is actually something we do want to set. I think. Oh, wait. Is this a full screen shader? Hang on. You know what? Let's just try. Let's just try. So... Oh, this might be a full screen shader. Play soul games like Sekiro, Ghost of Tsuniyama. You know what? The thing is about the Souls games, I'm actually not... I'm not that great at the Souls games. I've tried Elden Ring. I have Elden Ring. I think I have maybe Sekiro or maybe the other one. I'm not sure. I just don't have the patience for those games. That's the thing. And apparently I don't have like the reaction times either. Like I played Elden Ring, and I came to, I think I killed like one boss. I killed something, at least something that was like in the beginning of like a, well, it was like a bridge, I think. I'm not even sure if that was a boss or just a major enemy or something. But then I made it to some castle, and I started to kind of go into that castle. It's like a large castle of some kind, and like in the beginning area. And then I came into some other, like everything went great until... Oh yeah, I also tried to, like directly outside of the castle, there was like a camp, which I tried to defeat. I could defeat like every enemy, no problem, except for the last enemy. That was like some kind of lancer type enemy that I tried over and over and over again, killing all the enemies over and over and over again, and then I just gave up. So it's like, I don't know, for me it's not fun. It's fun when I win. But it's not fun when I try it over and over and over again. I have to do it over, like everything over once again, and die each time. And yeah, it's I have limited patience, limited time for that. And then there was another enemy like in the castle that was like in one of the rooms. It seemed to be optional, but I was like, hey, I'm gonna defeat this guy because I know it can be done. But I just, yeah, I couldn't. That guy was too fast. It was like a night in a dark room waiting for you. It didn't work on my laptop. Mine's potato laptop. He played Sekiro. Yeah. It challenges ego. Yeah, I guess. Man, I wanted to be like good at the game, but yeah. I didn't have the patience to like continue until it's done. Okay. Anyway, I don't know how they do it here. Oh, they're like looking at texture stuff. I guess we'll just try and do this here. So let's, because what I'm thinking for this is essentially you could, since this is meant to be used in like a larger, like the whole screen, like a full screen shader, maybe what we could do is we could take the original shape that we're drawing, render that to a texture, increase the size of that texture a little bit, and then render that texture with the increased size with like this thing. So you would get the outlines as well. Maybe. We'll see. Okay, so we got the Sobol thing. Now let's go back here. Okay, that should be good. Let's go to set or demo, I guess. No, we don't need this right now. I'm gonna go to, where's the player? And here, I'm just gonna add assets, shader key, Sobol. So the player should now be rendered with the Sobol shader. And it is. However, we're not getting like edge detection since it's kind of like outside. But that's cool. Okay. I died more than 500 times to bosses in Sekiro. Oh man. Like, yeah. I've played a little bit of like Dark Souls 1 and 2. I didn't have them myself though. But I don't know. There's something about those games that it's not really my cup of tea. It's like when you only focus on like the difficulty or like, because the story is like, I don't know. I'm not a huge story guy either, so I like gameplay, but I don't know. It has to be fun as well, without having to be super patient for me personally. Like I don't say that it's a bad game. Of course, it's a really good game, or the series. But yeah, it's not for me, unfortunately. Like I just feel stressed because I don't have the time to sink into it. Like, first it's fun, and I love exploring, so I love the open world aspect of Elden Ring and stuff as well. But then fun gets replaced with frustration and stress, and like then it's not fun anymore. And it doesn't. It also feels like I'm not improving as well. Like I can sit and play. I can sit and try again. And the bad thing is like it feels like I'm not improving. That's the thing. There's like such a small layer where you do like one small mistake and you're effed. You know. which is, yeah, it's challenging, and of course when you defeat the boss, of course it's gonna feel amazing and stuff, but I don't know, I just give up. So in essence, for me, creating a game is sort of easier because, you know, you can't really fail in a sense. Like, as long as you keep working on something, you're gonna get like, you're gonna do progress. But it didn't feel like that in Elden Ring for me. Okay. I mean, probably if I kept going, I could probably beat it at some point, but I just don't have patience for that. Okay. Okay. The thing about the Sobel, let's look at the Sobel effect, because I want to try this as well. The Sobel. So how large are these outlines? Not sure. Resolution XY. What if we change you to like 32 by 32? I'm not sure how large the player is. What if we change it to 4 by 4? Okay. Nothing seems to change there. But what I'm thinking is, like, since this is just drawing this part and the outline is like outside, right? So if I draw this thing onto a render texture that is like this size and then draw with the shader that texture onto the screen. So I'm gonna go to renderables and I'm gonna make a new one called, like, I don't know, shader sprite. Shader. Please try level devil kind of game with twist. Make one, please. What is a level devil? Is that what? Could you explain that? I've never heard that term. Level devil. Actually, what I'm gonna do... No, you can't actually have a renderable in here, because then that would be like an infinite size struct. Try once, it's a web game, super famous. You cannot beat it in one go unless you're Ultra Pro Max player. Okay. Okay, we'll take a little break. I'll guess I'll try this. I'll try it for a couple of minutes. Level Devil. It's a troll game. I knew it. It's you know, you can hear it on the name. Just making sure we're not going in some weird ass thing. Okay. Is this it? It will be fun. Great. How do you play? Why is this changing? press space. You know, I've seen like a thing about this. There's something gonna come up here. Yeah, there we go. I hate these kind of games. It's like trial and error. I really, really hate these games. I understand it's like content or something. Yeah, there we go. I failed. I mean, I will say the one thing that is kind of nice is like the anticipation of something that's going to happen, right? Okay. Oh my god, okay. Ugh. Yeah. It's playing with your the previous experience you had. Whoa. Are we gonna move? Yeah. Okay. I see 2 ways down, one that doesn't lead to death and another that does. Is this a double trick though? Why is there an open space to the left? Oh, man. I was trying to jump, but okay, I still do the same error. Okay, there we go. Super if you can make something crazy like this. Yeah, yeah, I don't know, man. I just hate these kinds of games. Okay, that was super easy though. Okay. Okay, a couple of more levels. Is it gonna come again? No. Okay. Ooh, that was too quick for me. Okay. What? Thank you for being a platform for me. And this is more like Super Mario. That kind of gameplay I like. What's gonna happen? Okay. Sometimes it's also fun, maybe sometimes to. I mean, I guess you know if you played what's it, the Super Mario Maker. There's a bunch of troll levels in Super Mario Maker. I was guessing there was like an invisible fall there. That was a trick. Like in Super Mario Maker, there's like a whole genre of troll levels. And you can kind of... Oh. Try to anticipate where the trolls... Like where the tricks and traps are. There's a few of these games coming out every now and then. Okay, is everyone gonna be like this? Well, you don't have to get them though. Oh. It's timed perfectly somehow. Okay. Okay. A couple more levels. Then I'll continue. Okay. This is the last level. No. Okay. Not that. Okay, there we go. That was the last level because that's the last level that you saw there. Okay. Well, as I said, I hate that kind of game because it's like a trial and error, and I don't know. Yeah. But yeah, I understand how it gets views and stuff. Like trial and error is not always bad, but this is like a purely, almost like a pure trial and error game. I don't know. I don't really like that. But it's fun to watch. It's fun to watch when people are like, yeah, getting. What the hell am I doing here? Okay, so, okay, we can't have a renderable. We could have a pointer to renderable. I guess we'll just have a. I guess we could have a sprite. And then shader, which is assets shader key. All right. And what we also need is like a render texture that we will draw onto. I'm not sure how good this is gonna be, but essentially, yeah, it's just gonna be like really render texture. I guess it doesn't have to be 2D. Is that the same thing, or is, I don't know. Yeah, it's the same thing. Okay. I think maybe their ego gets hurt when they're rage baited, so people watch them. I think it's more like you just get frustrated because you're trying to complete the level, and you maybe sometimes you get frustrated yourself because you do the same mistake twice. I did that a few times. I don't know. Okay, so we got a render texture. We have a shader key and a sprite. Okay, so then let's do. So draw will. So we will draw onto. Now this is the thing. Because right now it's like, what if? So does the so if could I get the previous render texture from Raylib? Get texture. What? Shapes drawing. What the hell is this? Because what I'm thinking of, if I say, for example, begin texture mode, then I won't know the previous. Like if we already had a texture mode, I'm pretty sure we're kind of overriding that now. Code guy, I mean, why do you care? Just leave them there. I don't know. You have more than me then, I think. I mean, I guess we could store the current texture mode, I guess, in game. Use game begin texture mode instead, and have that as a kind of like a stack of textures being rendered to. How could we do this otherwise? Service dead, no use of having more people. Alright. You do what you want to do. I'm gonna look this up first. Raylib texture mode stack. Sprite stacking. No, that's not what I want. The hell's this? Blend mode? Oh. Cool. No. However, there are examples in Raylib on how to render. Wait, Raylib examples. Shaders. Here, shapes, textures. Model shader. Okay, but how do I... No. Oh, OpenGL 1.1 does not support shader. What? So what is version 100 then? Okay, anyway. So we have a grayscale shader, watermill diffuse, watermill object. So you just draw directly. Where's the shader? Where's the shader used? What? Oh, okay. Model materials. Oh. 10 years of web dev, then you got bored of web dev, right? I mean, I'm not bored like 100%. Like, it's still a very useful skill to have to be able to like build things. You know, it's very popular. It's a very good skill to have if you want to find a job. And I'm not like I'm kind of bored. More what I'm bored with is like working for some other, you know, for some group of people. I don't know. I want to work for myself. Or I mean, I don't know. Maybe I haven't found like a workplace where I feel like, hey, I feel like this is, you know, I'm making like a difference or something like that. I don't know. I'm just tired of work. I just want to. I've tasted the freedom of kind of working for myself a little bit, and I want to get back to that. Try for Meta. Meta, like Facebook. You want to be free from Matrix. I don't want to put it like that. But sort of, I guess. Okay, so here they're using like the 3D stuff here where you have like a materials. So this is like specifically for 3D. Right. And this one is... Wait. Yeah, this is like the grays. The gray... Why can't I move? Oh. I'm like moving with the mouse scroll wheel. Okay. So that was not really what I was thinking about. Palette switch, texture rendering, texture outline. Oh, actually, this is kind of exactly, I mean, this is kind of adjacent to what I'm thinking here. Change, scroll to change the outline. Interesting, interesting how it happens over here. We have a thin. If the outline is thicker than the thing it's trying to draw, it's sort of like drawing a bunch of, I guess, a bunch of shadows. It's like 4 different shadows. It's drawing in different positions. And then it's just changing the positions of those shadows. Or something. Why not do like PewDiePie as a gamer, coder, artist, all-rounder guy, same as you? I think it's more... Yeah, I don't know. That's so easy to say though. Hey, why not just do like this? I mean, why not just do like, you know, Bill Gates or Elon Musk or something. There is Russian guy who had only 1K subs. He got laid off from Academy, posted a video went viral. Shit. Yeah, I mean, good for them. I'm out here. I'm just, you know, okay. So I'm kind of trying to do 2 things at once, almost. Like I'm trying to grow my channel, and also what I'm trying to do is build games that I can sell. So that's those two things that I'm doing. I'm learning about making games, and I'm trying to build games that I can then sell, and then and also grow. But in the same time, I'm streaming everything and like trying to grow my channel like that. So that's what I'm trying to do. You're not posting shorts or videos. You should have reached 1K, but yeah, but the thing is, like, I didn't really have time for that. Like, to make videos, it takes so long. Like, to stream, it's just the time that I stream. That's the only time I put in to the streams. That's the only time I have to put in. And that's super easy. So that's why. It's like, to make shorts and videos, I have to put in a lot of effort. Which is cool. I mean, yeah, I think videos gives you more... gives way more like stuff, like views and stuff, than live streams. I mean, even just a simple video takes a long time. Like, you have to edit, you have to like cut a bunch of stuff, you have to sometimes put stuff in there, you know. It's not easy, just because it's you know, if you look at some of the YouTube videos that people are making, you don't realize like how much effort they're actually making, like putting down to actually make those videos. And the thing is, like, I just didn't have the time to do that. That's the thing. I was working my day job. I have a family, so it's like there's no time basically to do that. If I want to also work on games at the same time as well. So like, yeah, I'm not married, but I have a family. We've been through this, Code Guy. In my country, you can have a family without being married. Because marriage is like, it's not as important as in other countries. Yes, living. Yes. That's why it takes up time from me. Otherwise, it wouldn't have taken up time if I had a dead family. Okay. Anyway, let's look at this here. So here's the texture. Here's the outline. Now, are you just going to do a full screen of this? I guess what we could do, maybe we could have a reusable shader that we could, or a reusable texture that we could draw to, maybe. Actually, this... yeah, this draws like everything here. Okay. Because what I wanted really was to have like multiple, and then maybe like another full screen. So this outline is not like for every, like it's only for some objects and not for all objects. What's this? Background is painted and animated on shader. Okay. Texture waves, set, set, fog rendering, hot reloading, simple mask, mesh instancing, multi-sample 2D. What is this? Multi-sample 2D. Multi-sample 2D. So we're making a red texture, the size of the screen, and then a blue texture, and then we have a shader that, and we put in another texture. Where are we doing that? Wait, oh, so we're doing it here. Why do we, do we need to do it after we do begin shader mode? No, because we're setting shader values here as well. Because what I'm thinking, like, this shouldn't change, right? So we need to do this every time. Maybe Raylib, like, removes, overwrites it or something. Additional textures are enabled for all draw calls in the batch, but end shader mode forces batch drawing and resets active textures. Okay, there we go. This way, other textures can be activated consequent drawings. The downside of this approach is set shader value must be called inside the loop to be set again after every end shader mode reset. Okay, that's why it's in here. And also, it will be for every other draw thing in here. Well, that's fine. We're drawing text red using default sampler to the texture 0, but an additional texture units are enabled for text blue, sampler to the texture 1. Right. So we're basically passing in two textures. The first texture is automatically passed from Raylib, and then we manually pass in the other texture here. And then we draw the red texture. Okay. And then the shader takes care of like mixing those two. Okay. But that's not a huge mystery now, I guess. Spotlight rendering, hybrid deferred, shadow map texture tiling. Okay, well, whatever. So basically, we can have like per, we can have per entity shaders. It's just that, I'm gonna delete this by the way. It's just that the shaders can't really draw like the area that you're drawing is not larger than, it's like it as the same size as the entity, like the actual sprite there. Unless we, unless we increase the size of the texture from the start when we load it in, we draw, then it's kind of like we're expanding the texture out a little bit. Maybe, or what we also could do is, let's say we draw the thing, let's say we have a Sobel shader that's in like full screen mode. And then we pass in to the shader, we pass in like a filter that filters out no, I don't know. Like we can maybe mask it somehow. I don't know. Anyway, we have kind of like done sort of basic shader things now. I'm gonna try do this. I'm gonna try and add the Sobel shader to this animated sign thing. As well. And it becomes dark here. Yeah, that makes sense. Okay, what do we want to do? Do we want to do something else this stream here, or do we want to... Am I too tired and need to go to eat? How far have we gone? Okay, almost 3 hours. What else? What do we want to do? Do we want to do something with shaders? Because I was thinking another thing that I do want to have is the spatial grid system. I want to have like dynamic objects checking for collisions. So like basically optimizing collision detection using the spatial grid system. Or we could also implement a sweeping algorithm. Actually, yeah. Okay, so here's my game jam project that I did for Raylib 6.x game jam. And it's working fine on desktop, but when it's running on web, it's like it starts to lag after you get to a certain point. It probably does as well when you're playing on desktop. And now I'm just playing my game here. So what I'm thinking is that I want to do some performance testing. So let's go to the game, and I'll set you to dev here. I have to remember to change that later. And we're gonna set you to like debug. Okay, so we have a special debug mode, and we need debug update function and a debug draw function. Okay. oops. And draw debug is essentially just draw gameplay. Update debug. Also going to be, yes, performance test, exactly. It's also going to be like update gameplay. And that's basically it. The only difference is the setup, essentially. Actually, so we're so actually it's this that we need to change. Setup entities, create player, yes. Create systems. Now, I think if we have well, I guess we can still add the system, but the update gameplay. Actually, yeah, then we don't want to do this. So we're gonna do like if screen state is equal to debug, or if it's not equal to debug, then we do this. Okay, so that was essentially just disable all the ships. You have Evo Fox Ronin keyboard? No, I have DAS keyboard. Yeah. So now there's no ships. There's also no way to actually complete the level because the system that handles that is disabled. So this is gonna keep on forever. But what I want to do is I want to create a bunch of things. So create entities, where is that? Set up entities. So we're gonna say like if we are in debug mode, create entities debug. So I'm gonna fill the screen essentially with a bunch of stuff. So we'll have columns is gonna be maybe 40 and rows 80 perhaps, and we're gonna calculate, we're gonna get fx is a float x, float from int x, and fy, and then we're gonna get the position. It's gonna be get absolute position of fx and fy. However, these are gonna be divided by columns and height of rows. Divided by columns, divided by rows. Okay. And now we should have a position that is good to use. So now we can create our shard. Oh wait, we already have this function, create debug shards. Oh, okay. So I'm just gonna create the debug shards, calling this function. This basically does the same thing, but I was over here. Okay, and this was the last thing that I need to do, just create the thing, add a shard and stuff. Okay, so we should be getting a whole bunch of shards now. Interesting. I think At some point the mouse position was at top left. And so you got a little distortion up there. It's kind of like a black hole. Oh yeah, I was using this to be able to see... also, what's going on the right side of the screen? I was using this to be able to see if the glimmer effect or the shimmer effect was working. It almost looks like you're dragging a fabric around. Okay, well, anyway, this is to be able to test a little bit the FPS here. So, there we go. Now, the thing about what's happening here is that every shard you're seeing on the screen, every green piece you're seeing on the screen, is being checked against the player for collision. Right? That's what's happening. Now, what we want to do is we want to optimize that. That's called a brute force algorithm. Sort of. Like, it's because we're checking as every possibility instead of trying to optimize to reduce the amount of checks that we want to do. So what I want to implement is the sweeping algorithm, I think, for this. But the sweeping algorithm is like, the sweeping algorithm is good for checking all bodies against all other bodies, I think. Now, you could also do like a quad tree, where everything is being entered into a quad tree, and then when you check things against other things, you only have to check some of the things because you kind of partition everything into separate rectangles. That's what you do with a quad tree. You kind of separate into regions, and then you know if I'm in this region, I can check against everything that is in this region. And I don't have to check other regions because I know I'm not in those regions. But the sweeping algorithm, let me see if I can remember this correctly here. Yeah, so essentially we can use the sweeping algorithm, but I have to modify it to be only for one body, I think. But it's very good for checking everything at once. Like getting collision detections for everything at once. But what to do there? Or we could also do the grid spatial thing. I got a laptop stand for $4. Now my laptop is cool. A laptop stand, what is that? Let's go over to where this is happening. So this is happening in the grid. No. It's happening in shard. No. Player system. Pick up shards. Right. So here we're iterating through all the shards. And we're getting the distance to the player distance square, so we're not doing a square root here. I wonder how much the thing will go down if we use the square root, if at all, because sometimes you get like hardware powered square roots, I think, or something like that. Anyway, okay, so then we're just checking, okay, distance. Okay, so we don't do like an AABB check. We actually just get the distance. So it's a little bit more efficient, I guess, maybe, than checking for AABB collisions. So they're kind of like circles. This makes like the player like a circle in this sense. and all the different shards also. So, but how, okay, so how do we improve this? The problem is iterating through all shards at once and checking against the player distance. So what you could do is, I mean, we could divide, like if we did like a very basic quad tree, we could divide checking in a quarter by making 4 regions that divides the screen in 4 regions, and then inserts every entity into those 4 regions. And then when we do a distance check, we only need to do the check for the ones in the region that we're concerned about. And then you can do even more if you do this recursively. So that would be a quad tree. I'm just thinking what the best approach here would be, or not the best, but a reasonable approach with the tools that I have. Let me actually go here and search for sweeping algorithm one object. Okay, sure. Let's see. Yeah, the thing where sweeping algorithm is really good for, like, if you like, it quickly eliminates a bunch of candidates essentially. Okay, you know what? I'm too tired actually to do this right now. I've been a little bit sick actually, so I'm gonna cut off here. I've been going for long enough. So anyway, but yeah, that was really cool. We got like shaders going, and yeah, that's really cool. Now I can actually figure out if I want to employ that in my game and make the graphics look a little bit cooler. Yeah, there's so much work to do though in the Metroidvania, but I'm not sure if I'm gonna make like a game in between here before I get back to that one. But we'll see. I've been working on the template project a lot, and yeah, that could be used to start up new projects pretty more quickly than I could before. But yeah, I'll see you tomorrow, and have a nice day in the meantime. Thank you much for watching.